So we're going to begin our next session. So this session is on the topic, realize the value of data with Splunk, AI, and Amazon Security Lake. This is a level 200 session. So it's my pleasure to welcome to the stage Cloud Technology Strategist, APJC of Splunk, Trav, T-Rex, Kane. Please give him a big round of applause.
Good afternoon, everyone. Show of hands, someone wave up if they can hear me okay. Hey, thank you, great, well done. And yeah, as I mentioned, my name is Trav, or T-Rex Kane. You're probably wondering where the T-Rex came from. If you're not aware, I'm 6'2", quite a tall kind of individual. Used to play a lot of cricket in my junior careers. And whenever a ball went over my head and I couldn't reach it, even at 6'2", they were going, short arms, short arms. So they call me T-Rex. Now I tell you that story because a lot of people think of another story where they think when it comes to paying the bill, I've got short arms and I can't reach my wallet. So that is not true. I'm a very generous person, so please, if you hear that rumor, tell them the cricket one, okay? All right, so let's kick off. If you've ever seen a Splunk presentation before, you would have seen one of these slides. Effectively, it's a forward-looking statement slide. Sometimes the technology we talk about is still coming about or coming available. So please, before making any purchasing decisions, reach out to your Splunk team and make sure you get the latest information before purchasing. As much as I would love you to all go out and sign a multi-million-dollar contract with Splunk after this session on the back of this, but please double check for everything. Okay, so before we go down the journey of today, I thought I'd start off with a little bit of a story. Is anyone from Deloitte in the room? No, maybe one person. Deloitte released an article late last year that talked about the amount of data we are generating as a group of individuals on this planet. And it's tipped that this year we're going to be generating 175 zettabytes of data. Now, when I first read that, I'm like, what does that number even mean? That's a lot of data. In fact, when you look at this year's stats, it's actually going to be close to 178 zettabytes of data. So I thought I'd take that one step further to visualize it for you to kind of set the scene. Does anyone remember these technology? I'm kind of a bit older. You probably remember Blu-rays. Yep, what it looks like. A single-sided Blu-ray, that's even the older generation of Blu-ray, holds 25 gig of data, single side. And it's 1.2 millimeters thin. So, if we tried to fit that 175 zettabytes of data onto Blu-rays, we would need 7 trillion Blu-rays. That's a lot of Blu-rays. And if we stack them on top of each other, we also need 8.4 million kilometers to lay them all out. That's a lot, isn't it? So hopefully at this point, that's a lot of data. You can kind of start to visualize. Let's take that one step further. If we look at the Earth and the Moon at its closest orbit, we're looking at about 363 kilometers between us and the Moon at its shortest orbit. If we then stack those Blu-rays out, we could reach the Moon 23 times. That is unbelievable amount of data. And that's just in 1 year alone. You can imagine what it's going to be like as we go forward. So why am I telling you all this? Apart from having a cool analogy and different things to think about, any data platform you use today, whether it be Splunk or your own data platform, you can no longer afford to just throw all your data at it. Especially since COVID, when we've now got all these different data sources to deal with and it's continuing to grow, it's not cost effective to throw everything at your platform and just expect it to work and scale. So we need to think about it differently. And that's one thing that Splunk is spending a lot of time with, and you'll see a lot of our messaging and help with our customers around how do we deal with that mammoth amount of data. So we tend to want to classify the data. And so at a very simplistic form, it tends to come down to 3 major categories. On the far left, we have the pink dots. And I'll reference it throughout the presentation, the pink dots, so you kind of make sense of what I'm talking about. The pink dots on the far left are a representation of your hot, your critical data. That's the stuff that's generating security threats coming in when you want to know if you want to do forensic threat hunting, or potentially your IT operational data. It's the stuff that we care about because if we don't have it, we've got visibility gaps in our environment and we're potentially at risk or potentially don't know about an outage or something coming up. Now on the far right side, we have the gray dots. Now that's the data that we don't necessarily care about right now, but we don't want to get rid of it because potentially it's critical for our compliance or potentially during a forensic investigation. So we still need that data, so we don't want to just throw it out. But it shouldn't be treated the same as those pink dots. And then over a beer, we can definitely have a conversation around the orange dots. That really sits in between that, and it really comes down to your preference as a company and the way you use it and what you need out of that data. You can kind of see where I'm going, that you need to classify that data differently in the way that you use it and consume it. Now that's just your data. On top of that, companies are really struggling with 4 key areas inside that data. It's ingestion. There's so many different sources nowadays from different areas, different formats, whether it be CSV, JSON, space separated, Parquet data from different locations, speeds, feeds. How do I ingest it all in the one platform without having to have 12 different tools to do that? And then how do I process that data? It's really complex. What do I do with it? How do I process it at scale, massive scale at that hundreds of terabytes? And then landing that data. Again, back to that pink and gray dot, I want to choose different places that are cost effective to put that data somewhere and have the choice to do that, again, without having 7 different tools to help me do that or a complex setup. And lastly, you want to manage all of that under a nice ecosystem that's easier to use and consume. And that's all the challenges that we're having today in the market and we're seeing in the market as well. So, how is Splunk helping users manage that crazy landscape that I just kind of described? So in the kind of elevator pitch, we have this thing called Data Management Experience, or we acronym everything DMX. Effectively, Splunk can take any human readable data in any format, any structure, bring it into our platform. But not only that, in the data management platform, you also have the capability to filter, mask, redact, route, enrich that data as you see fit. And then you have the choice to route it where you need it. Whether it's our platform, whether it's a S3 bucket or a giant storage data lake, you have that choice. We also have our Splunk Observability Cloud. If you're not familiar with that, it's more attuned to doing metrics and traces. So that's another option as well. So that's kind of the holistic of the data management experience for Splunk and that choice. Now, if we take that one level down, we also help our customers out in different ways. Now, the focus of today was on the far right-hand side, but I wanted to quickly touch off a couple on the left. So when you ingest data into Splunk, traditionally you have a license, and there's 2 major ways you can license the platform. We have our ingest model, which is generally how much data you're ingesting per day, and your license is kind of based off that. But we realized customers want to ingest a lot of data, but potentially do different kind of use cases on it in different ways. So we introduced something called a workload-based pricing, which think of that as a giant compute bubble. So therefore, it doesn't matter how much data you throw at it, it's when that compute resource becomes a problem and the bubble gets too tight, you need to grow it out. Or as I'm getting older, loosen my belt. That's kind of how that works. And on top of that, again, that storage, as that pink data becomes gray, you need a simple, cheap, easy way to archive it to cheaper storage. So we've got kind of 2 major ways we can do that. We have our DDAA, or our archiving capability, that's Splunk managed. Again, we can tier that off to an archiving capability cheaper for you. Or you can bring your own storage, something like an S3 bucket. And then you can control that in your own environment and archive it off to that. But I guess the categorical question on that point is, you've already chosen to send the data to Splunk at that point. So you're already committed. You've already kind of paid the licensing at the front end. We want to offer you choice at that point of saying, do I have to send it to Splunk? And that's where the other 2 come in. And that's what we'll spend most of this conversation on today. And we unpick that a bit further. So let's look at GDI and data optimization. Acronym for you today, GDI, getting data in. So if you've played with Splunk for a little while now, from day one we had this thing called the heavy forwarder, or HWF as we call it. Hopefully you've all heard of it. But from day one, heavy forwarder allowed you to manipulate the data. A lot of people don't tend to think of it that way, But in our props and transforms configuration files, you can write regex and manipulate the data, drop it, change it before it gets sent to Splunk. Always been there for like 20 years of our platform now. But the challenge with that is that you need to know what you're doing. From an architecture point of view, looks something like this. On your side, you would send the data to the heavy forwarder. That heavy forwarder then gets sent to Splunk. And the benefit of that architecture is that you can potentially drop some of the data before it egresses the cloud. And why would you want to pay egress costs when you're just going to get rid of it anyway? So that's a great way to do that. But as I said, the big challenge with that is how does that scale? You're going to have 100 heavy forwarders. You're going to manually log into every one of those forwarders, edit the conf files, know what you're doing. How many people still use Vi anymore? Like I still log in and do that and hack those conf files, but you don't know if it's even going to work. Like you're going to have to type it, see what happens, look in the Splunk console, did it actually do what I wanted it to do? So it wasn't very effective. So about 2.5 years ago, we introduced this product called Ingest Actions. And this added a UI over the top of that configuration capability. But it gave you some great advantages. One of the biggest advantages was the ability to see real time what happens if I apply a rule set and hit sample. What is it going to look like? What's it going to look like at the end of this thing when I apply this rule to it? So that you can see live what's going to happen and be more confident when you hit the save button, what my data is going to look like at the other end. The other cool thing we introduced at that point in time was the ability to route data or clone the data to S3. So now you're in a really good position to say, well, I want to do a subset of data to Splunk, that's the critical pink data, and all that gray data stuff I don't care about now, I'm going to route that to S3, and you can split it right there in the rule set. That's a great way of doing that. Now from an architecture point of view, it kind of looks a bit like this. You can see the kind of, again, the forwarders are sending to a heavy forwarder. You can actually install the Ingest Actions UI on the heavy forwarder. So again, saving that egress cost. Or it's already running in, if you're a Splunk Cloud customer, the UI is already built into the Splunk Cloud, so you can manipulate it there, but of course you don't get the benefits of the egress thing, but again, you don't have to manage the heavy forwarder either. So you kind of get those two options for Ingest Actions. But then hence come the next challenge, as the data grew, and we needed to have lots of those forwarders or lots of Ingest Actions, you needed the capability to be able to write very complex pipeline. What if you want to enrich the data with additional sources? What if I wanted to manage 300 heavy forwarders? Ingest Actions, again, you still get the problem of having to install it on every single heavy forwarder. It's great that you can sample the data and see what's happening, but you still have to manage that giant landscape. And you also got no real metrics on what's going on. How much data was coming in, how much data was coming out? What's the health state of those heavy forwarders or Ingest Actions? So we took that one step further. About a year and a half ago now, we introduced a product called Edge Processor. Now this really stepped it up. From the Edge Processor, we introduced a unified management experience that, and trust me, less than 2 minutes, you could grab the command, run it on an EC2 instance, and it'll dial home and connect in, and your Edge Processor is up and running. We even run a workshop on it. It's called a DMX workshop. Again, hit me up after this if you want to run one. I can run one for you. It's a great way to configure that. So you can start deploying Edge processors at scale. They all dial back home to the management experience, and you can see what's going on across all my Edge processors. Now the other great thing is your pipelining. In that DMX sort of unified management experience, you write and author your pipelines. We use something called SPL2. It's really robust, really easy to use, and you can do so much with it. Now the benefit of that is you can write the pipeline once and push it out to all the edge nodes with a single click. Tick the box, push it out. And again, it'll monitor the status of it. It'll change from green to healthy to purple, saying it's updating, and then go back to green. Or if it goes red, of course, something's gone wrong. But you can do that from a single unified management experience, which is great. We also introduced different kind of formats that we support in that product as well. So you can kind of see where we're going with this whole management experience to be able to manage all these pipelines in a single location. From an architecture point of view, very similar to the heavy forwarder ingest actions architecture, where it sits on wherever you want it, again, saving your egress costs. The EC2, I guess, managed by you, but then we can help you manage the edge processor through that management experience. And again, then it gets sent to the indexes. So it kind of adds an extra layer, like you can go heavy forwarder to a edge processor and then into Splunk. Technically, you could also do an ingest actions into edge processor into Splunk. Don't know why you would do that, but I'm sure someone probably has. So the challenge, I guess, that came out of that is a lot of our users and customers said, I don't want to manage edge processors. I just wanted Splunk to take care of all of that for me. Just take it off my plate, please. So last year, we introduced ingest processor. So that is a fully Splunk managed cloud processing capability that sits on your Splunk cloud instance that you can then scale. Splunk takes care of all the scaling. So it just sits there, you can throw as much data as you wanted it, and it scales, and we do it all for you. But as it's a new product, we also wanted to add some additional features, and these will eventually roll down to the edge processor, so don't worry. But the first off the bat was the ability to route out to our observability platform. So again, you've got a choice between different platforms now. So the Splunk Cloud or Observability Cloud. And the reason we did that is because it introduced a new cool feature. I call it metrozation. Try and say that after a few beers, it's quite difficult. Metrozation is the ability to take a log and convert it to a metric. And the reason why you do that, let's just take a Windows event log. We've all seen a Windows event log hopefully before, and they generally have that UUID or some kind of ID, the event ID at the top of it. If all you care about is how many times that ID has occurred over a given period of time, and then therefore we want to go and investigate something, I just want to trigger an alert, why are you ingesting all the log? Why can't we just ingest the metric and send the logs to Amazon S3? Great way to optimize your data. And so the metrozation process can do that. You can route the logs themselves to S3 and only convert them to metrics and send that to Splunk only. So that's a great feature of doing that. And again, observability is the best product to do that at scale. From an architecture point of view, looks like this. Now it looks exactly identical to the edge processor one. I've just adjusted the dotted line to the left because it's managed by Splunk. Now, I've missed one key valuable point with all of these different things I talked about today. Every one of them can be used for free if you're a Splunk customer. That's pretty cool. Okay, so now we've talked about all the routing and capabilities around changing and manipulating the data. What if we sent all of that grey data on the far right-hand side, the less valuable stuff, to a Amazon S3 bucket or a data lake? What options do we have? So I wanted to talk about a couple of options we've got. We call it searching data elsewhere or federation of data. So the first one is Splunk's federated search for Amazon S3. That gives you the capability to be able to search inline on an Amazon S3 bucket without actually ingesting the data. You search in place, querying the data. How does it work? You basically, on your side, you would configure the Glue catalog schema. If you've Amazon conference, hopefully everyone's familiar with Glue data catalog, but that defines the structure of the data that sits in the Amazon S3 bucket. So it's important you kind of configure that correctly, and I've got a whole workshop coming out to market soon on that. Come and hit me on the booth on that. But once that's configured, we set that up in Splunk. We tell it which Glue catalog we're going to look at, and which S3 bucket we want to search as well. And Splunk, using our SD select command, can then search that data inside the Amazon S3 bucket and poll it. So one of the challenges I want to mention on that, though, is that because we're not ingesting the data, we have a different license type, and we call that data scanned units. And so it's like a prepaid credit card. You buy a prepaid amount of data you would like to scan. You can top it up anytime you like. But it's important because if you don't structure the data correctly and you run a poor search and it runs across the entire multi-petabyte S3 bucket, guess what? You're going to scan the whole data. So it's important we, again, structure that data correctly. But you're probably wondering, what are the use cases for this kind of layout? So it's not made for threat hunting. Threat hunting is, I want the data all the time, continually polling, continually searching, not the best outcome. The best use case for this is forensic investigations. If you think about a forensic investigation, you generally have a point in time where you'd like to search. You've detected a threat, and you said, okay, I'm going to go back to this period of time, this last week, we think that's when the exfiltration or something happened. How do I go back and I can search those logs specifically in that point in time and get my results? So I haven't had a random amount of logs coming into Splunk for no reason. I'm only searching that data when I need to for a forensic investigation. Now the second one, historical analysis, that's a fancy word for the same thing. We're just searching back in time for an analysis. But the last one, which is cool, is data enrichment. If you're running a report and you want to pull out some additional data out of S3 for an enrichment capability, great example of where that's really useful as well. So again, you've now got that choice of your hot data and making the valuable data only, and then searching data elsewhere when you need it. Again, giving you a great way to optimize your data and reducing your cost overall. But what if we're using Amazon Security Lake? Is anyone playing with Amazon Security Lake today? Again, I hope, again, Amazon conference, you're familiar with Amazon Security Lake. What you might not know, Splunk worked with Amazon from day one of that product. It used to be called Project Moose, a fancy little name. I'm not sure if I'm supposed to tell you that, don't tell anyone. Project Moose. We work with Amazon alongside that, and that's because it's underpinned on the Open Cybersecurity Schema Framework, OCSF. Splunk was one of the first people to come out and launch that open source project. ASL is backed on that. And effectively, you can take all of your data, send it to the Amazon Security Lake data lake. Third parties can do it as well. Put it all in the data lake, but then you go, okay, it's in the data lake. How do I get access to it? And so Federated Analytics was a product we launched, again, around about the time Amazon Security Lake came out, to allow customers to consume the data out of Amazon Security Lake. So if you're going to take away anything from that, if you're using Amazon Security Lake, can I still use Splunk? Yes, tick box. And it had two main goals when we launched the product. Again, back to that pink hot data and the gray forensic investigation data. This product had to solve both those use cases. And so it does that by a simple architecture where we have two types of indexes. Using the Amazon Security Lake, you configure what we call data access and query access. And then the Federated Analytics product can simply connect to it. And if it's a data access, we pull the data out in what we call a temporary index. Think of it like a cached index. So again, we generally recommend about 30 days is what we do there. And because it's still in Amazon Security Lake, you don't need to worry about archiving. It just purges the data and you just keep this rolling 30-day window going through. Again, that can be configured, but we kind of recommend 30 days. But then the old data, again, we want to search. For forensic investigations, we have what's called a federated index. And that works exactly the same as federated search for Amazon S3, but against Amazon Security Lake. So giving you the full flexibility of both those options using federated analytics. Hopefully that makes sense. And again, happy to chat about this at the booth. Now we can't have any conference, you probably thought you got away with it, without mentioning the word AI. I'm sorry, we'll have to do an AI bit. But how is Splunk AI helping you drive that value out of that data once you've got it in? So you've made all the right choices, you've streamed the right stuff. What is our AI portfolio talking about? Now for those who witnessed my presentation last year, I did a whole presentation on AI because that was the buzzword at the time and still is today. But I wanted to cover off the two fundamental major chunks from a Splunk perspective. On the bottom layer, we have the ability with our machine learning capabilities to be able to analyze your data at scale, massive scale, to be able to detect, predict, pick out outliers, anomalies at scale using the machine learning capabilities in our product based on use cases and different things you can do. Over 10 years we've been able to do that. We've nailed it. But what's more recent times with the introduction of generative AI is what we call basically making everybody an expert. And so I wanted to cover off quickly those three things we launched around generative AI capabilities. So in more recent times, we announced our Splunk AI Assistant. Now, if you've played around for Splunk for a while, you may have heard the term, I love Splunk because it can do just about everything. But in the same sentence, you'll hear, I hate Splunk because it can do just about everything. It's confusing. The SPL is so feature rich, it takes a little bit of a level set to get up to speed of how to use it. And so this AI assistant means that you can, in English, ask it a question and it'll spit out the answer in SPL for you, greatly bringing up the bar of experts. You can also go around the other way. If someone sent you a giant complicated SPL statement, and we've all done that to someone in the past, then it'll convert it to English for you, and you can ask it questions on it. So that's our AI assistant. Now this year we've also gone one step further. We've introduced agentic AI into our assistants, specifically for the observability platform and the security platform. And the benefit of that is that especially in the observability one that's now launched, is it not only just gives you an answer, it actually goes off and does some investigation for you. It actually takes a lot of that kind of low-level stuff out of the way, runs off and does all these different things, comes back and helps you find that problem faster. And the security one will be out probably later this year. But at the end of the day, what's it doing? It's really about reducing the amount of time it takes to find an answer. We're seeing in the market and observability, when we're trialing this with our customers, we're seeing the average observability incident is reducing from 40 minutes down to 7. That's pretty cool. So a lot of those tasks, again, because of the agentic fashion, is being reduced. Now on the security side, we're seeing much greater reductions in time. And that's generally because when you get a security incident, there's a lot more stuff you have to worry about. And again, a lot of those things are taken out for you. We're seeing hours to minutes, which is pretty cool. And it's not just us saying that, it's our customers as well. No surprises across the board. Anyone who's using these assistants or trialing them is seeing a reduction in the amount of time it takes to find a problem. So hopefully that's pretty cool. Now I've got some good news for you. This is my last slide. And there's about 2 minutes left, so I'm going to ask you a favor. We're on our real silent disco. When I say go, I want to do a round of applause, we're finished. I want to make it so loud that the people over there are going to go, what was that session? I've missed something out in the best session ever. I'm going to be so jealous. So are we ready? 1, 2, 3, we're done. Thank you everyone, appreciate your time. Hope you enjoyed your day. Come and see us in the booth.